need to actually brush like your teeth, like you brush like on top, like the sides, in front, behind as well. Because most people need to brush their teeth behind. You have to also brush your teeth behind as well. Afterwards, you also have to brush your cheeks as well. Just like swab your cheeks too. Yes, you have, yes. If you don't swab your cheeks, you haven't brushed your teeth. Oh my goodness, this thing that okay. Yeah. So on today's, what we'll be looking at today, we'll be looking at the sum and the product and inverse of the suites. Just generally how they're brought about and what goes on when you're looking at the addition of two suites, the product of two suites, and if you're dividing suites and when they're inverse and everything like that. That's what we'll be looking at today. So first and foremost, I want to start by talking about the sum of two suites. When you look at the sum of two suites, it means that there are two things you're going to be adding. Yeah, there are two things you're going to be adding. So first and foremost, in this case here, we've got two common suites that we know. We've got a suite UN and a suite VN. And then when we add these two suites, they give us another suite, which is WN. And knowing that each suite has got a particular limit, and we all know that the limit of the suite UN is L, whilst the limit for the suite VN is L prime. So, meaning that WN is actually going to be L, that's actually going to be L plus L prime, basically, when you look at it under limits. So basically, we're looking at the sum of the suites. You have two non-suites, which you all know. We have VN and we have UN. And sum means addition. And each suite has got a limit. And the limit for the suite UN, we know, is L. For the suite VN, we know it's L prime. So this is for the first part. Yeah. I hope we're all together. Yeah.
Question.
Yeah, sure.
Are they always two? Like, can they exceed two?
Huh?
Suites. Can they exceed two?
Can they exceed two? Yeah, probably. Yeah, they can exceed two. But then they can exceed two. But then in this case here, it's easier to show an addition of two suites. And like where, where there are a lot of them. Yeah. So at least if you see the concept of how we go about when you're adding two suites, there are two suites of the limit. Then from there, you will be able to apply the same concept when you've been given maybe like addition of three suites of the limit or four suites of the limit. Yeah, you get me?
Wait.
Yeah. Mm-hmm. So just as always, we know that whenever we're looking at suites of the limit, they always have to explain, rather define them. And how do you define a limit of a suite? You have to first define each part, because when you look at this equation here, we have UN there, we have BN, we have been given L and with L prime, and we have WN, which is basically the addition of UN and BN. So each and every single thing here has to be now defined. This is why when you go down, we now have this whole paragraph here, which is basically going to redefine the equation there, where it says WN is equal to UN plus BN. That's the whole concept. So just as always, just as we look at the other time when we introduced the suite, the limit of the suite UN where it was approaching infinity, we looked at epsilon. Yeah, we looked at epsilon, and that's something. Epsilon is a very, very small number. Neither is it 0 and neither is it 1. We just know it's a very small number. Yeah. So basically that's that. So first and foremost, here we've been told that, and here the thing is, the information here, the definition here has been fixed. Here it says that it's been fixed that the epsilon is going to be greater than 0. By definition, we already know that epsilon is a number that is neither 0, neither is it 1. It's a very, very small number. And when we say it's a very, very small number, meaning that already we know it exceeds 0, but it does not exceed 1. That's epsilon. And then here another thing we've been told is that the conversion here is epsilon over 2. And just as always, we know that there's always going to be a capital N, which simply is an equivalent of any number. And as usual, the small n is greater or equals to the capital N. And we all know that this n here is a member of natural numbers, just as always. The same concept as we have been looking at, the same things come about. And there can be a little difference of things, but otherwise it's the same concept. The same concept. It's still going to be n, small n is greater and equals to big N. We know the big N is a member of natural numbers that we know. The small n is equivalent to any number as well, just as always. Yeah. And then we've also been told that the suite UN minus its limit L, and when you find the modulus of the suite UN minus the limit L, that whatever it is you find should be less than the conversion of the same suite, which is equals to epsilon over 2. This part here. Yeah. So first and foremost here, what we can see from here is that in this case here, we're looking at the suite UN. That's everything here right now. The first thing we're looking at here is the suite UN. And by definition, we've been told that the conversion of the suite UN is with epsilon over 2 that we know it's been given, which is here. And then we've been told that epsilon is greater than 0. As usual, we know that there's going to be a capital N, and that N represents natural numbers. And those natural numbers should be less than the small n, which is here. Yeah. Then it goes on to say that we go on and then come to realize that, okay, that means when you get the suite, and when you get its limit, and when you do its subtraction there, whatever it is you find there, when you find the modulus of whatever it is you're going to find there, whatever value you find there, it should be smaller than the conversion, which is epsilon over 2. Yeah. So maybe let's say for example here, the suite here we were given maybe like it's let's say it's okay, let's say the suite we've been given there is 3x, 3n, 3n plus 4. Yeah. We've been given 3n plus 4. And then we know that the n there is going to be approaching L. Now that L there, maybe let's say the L there is 7, right? Meaning that in your equation, the way it says UN minus L, you write what your UN is, you write what your L is there. Then you're going to do some subtractions. Then whatever it is you find, you're going to now find the modulus of whatever it is you're going to find there. Whatever value you find here, it should be less than epsilon over 2. Here, noting that if you divide epsilon over 2, the value you get will be a very, very small value, very small value, because already we know that epsilon is already a small value. And now 2 is bigger than epsilon, that we already know. It's like saying 1/100, and you find what it's equal to. Meaning that whatever thing you're going to find here should be a very small number, because even when you just divide this on its own here, you find a very small figure. Yeah. So this is the part for UN. Last time we had introduced the suite BN. Yeah, we had introduced the suite BN. We said that, on Monday we were looking at BN and we were also looking at UN, and we came to note that BN and UN are two different suites. And we have two different suites. Yeah, we have two different suites of the limit. They also have two different limits of their own. This is why the limit of UN is L. And the limit of the VN is L prime. Why? Because they're two different suites. And today we're looking at the addition of two different suites, and we say UN plus VN is equal to WN. The WN will represent something, the UN something, and the VN something as well. And when you add all these together, when you add the UN and the VN together, it gives you WN. So basically, whenever you're looking at an addition of suites, one thing you should note is that you're going to be looking at different limits of the suites, And a limit of a suite and different limit of a suite is also going to come about different limits of their own. So you can't have, maybe at times you can have the same limit. Yeah, you can have the same limit. Maybe they give you one equation where it's 3n plus 4, and the limit you've been given is where the n is going to be maybe approaching the 2. And then the second one is going to be maybe 7n plus 8. Then the limit will be approaching 3. The other one can be 10n plus it can be 10n, 10n over 7 plus 7, plus 7. Then the limit can also be approaching 2, just like the other one. So quite just like any other equations, maybe you can find here the equation you've been given here. There was 3 had appeared. The other equation 3 also appeared. The same thing here. The limits can be the same. It can depend with the question you've been given. Yeah. Yes. Yeah. But then the reason why here they put L and L prime is for them to differentiate that the Vn and Un, they have their own limits. Yeah, they have their own limits. Even though by number they can both have 2. Even though by number they can both have 2, it doesn't matter. Yeah, it doesn't matter. But the point of them putting the prim on the L for the Vn is just to show you that each limit has its own. Each suite of the limit has its own limits. That's the whole essence of them actually doing so. Yeah. Yeah. So then we're now going to be looking at we're looking at Vn there. Just like the UN, the conversion, the conversion gives a capital M. The conversion gives a capital M in this case here. And then here we have been given a condition. It says if the small n is greater or equal to the capital M, meaning that so the Vn minus the L prime is going to give us the same thing, just like the UN minus the L. It's going to be whatever value you're going to find here should be less than epsilon over 2. So basically here the same concept, just like the UN, the same thing here comes about, except for Vn it has its own limit, which is L prime, and for UN, which is L. Yeah. And then for the Vn, they introduced the M. Yeah, they introduced the M for the Vn, and the M was not introduced. We're looking at the UN. The UN there, we're looking at the N, which we're all familiar with, and then now the VN here, we introduced the M. Last time when you looked at the M, we went forward where there was the small m and the capital M, and last time we said we ever have a small m and a capital M. Yeah, small m and a capital M. Now that small m is going to be a small number, what a capital M is going to be a bigger number. Yeah, that's what we looked at last time. We looked at when we had introduced the M. So the concept here remains the same, just like the concept had applied when we were looking at the UN. The same thing as well for the VN as well. The same thing here, the same thing here. The only difference is that for the UN, you have the limit there is L, whilst for the VN, the limit there is going to be the L prime. And then we all know where the epsilon over 2 is coming from. This epsilon over 2 is coming from here, and this is the conversion of the UN here. Yeah, this is the conversion of the UN here. We all know where this capital N is coming from. This capital M has been there from the very beginning, and then this capital N here represents numbers, natural numbers, and then this small n here, and then this small n here accounts from the fact that a suite is in function of n, because the symbol for a suite is UN. This is why we have the n here. This is why as we go there you find a lot of n's. Even the equation will be given of a suite. It cannot be 3x. It has to be 3n, because the suite is in function of n, not in function of any other letter of n. That's how it is. Yeah. And then we now come back to now deduce that we have the very small n. Yeah, the very small n will be greater or equals to the capital N. Last time on Monday we looked at the K. We looked at the K, where then the K was defined as being the maximum value of a particular suite, right? Now in this case here, the K here, the K here, the small n greater or equals to the K is equals to the maximum of the M and the N. And we all know what the M and the N here is. Yeah, N here is. this n here is also going to represent a number. It's also a member. It's also a member. Whatever value you find here, a member of natural number. Just like this capital N here. This m here is for the Vn, whilst this n here is for the Un. Yeah. And then just like the other one, and then just like the other one, we already looked at this here. It was defined here after we had deduced about the n and the m. We found that we found these equations here. The modulus of the un minus l would be less should be less than epsilon over 2. Just like Vn here, Vn minus l prime should be less than epsilon over 2. Yeah. So we found this. So this here we were given by definition, which is here. The same thing with the other one here, which is here. Yeah. So this whole thing here represents, this whole thing here is going to represent the suite Un. This whole thing here is for the suite Vn. This whole thing here represents as well, okay, whenever I see this, okay, there's somewhere there's going to be an n here. Well, for here, there's going to be an n here. According to what we've been told here, this is what we can also deduce. Whenever I look at such a thing, you should try and analyze, say, oh, okay, so from what I've been given here, what can I deduce? What can I see from here? What have I been given? So that you can make things be easier as you are trying to calculate or solve whatever it is you've been given. Because you need to get the concept and now see, okay, now how am I going to apply the concept with what I've been given? It's all about application. You read the notes, you get what you've been given, you write them down, and you get this the very notes, and you go and see the question you've been given. Analysis is all about applying your notes, because believe you me, it's all the notes. When you understand the theory, it will be easy for you to apply the theory in the wake. Yeah. That's how analysis is. This is what you have to constantly try and go through the notes. So at least even as you are solving, it's easy for you to solve, because what you do is you get what you've been given, you get your data, apply your data in the question. That's how you solve the question. That's how it's supposed to be. Yeah. Then we now look at this point here. This equation here is basically an expansion of this and this here. Yeah, of this and this here. Remember when I said that this UN here, this whole thing here is equal to UN. Like it not equal to, then like it represents the UN. And then here it represents the VN here. And then from the very beginning, we say that the sum of two suites is equal to WN. And which suites are we looking at? We look at the suite VN and UN. So UN plus VN is equal to WN. Is equal to WN. Yeah. And then we also know that whenever you have an addition of two suites, meaning that for WN, it's going to be converging towards, so it's going to be heading towards the L plus the O, because those two are the limits for each suite, for the suites which are being added. Yeah. So basically, yeah. So basically here, this is an expression of this. And then these two here, they were added, just like we have the general equation, which is here. So basically, let's say we replace this with what we've been given and this here with the other thing here, and then we just try to find some things. And then we also know that we know that the WN is also equivalent to something as well. Yeah, when you do some calculations. Yeah, this is now how you're now finding this whole thing here. It says the modulus of WN minus L plus L prime. This here represents the limits. And when you look at what it says, what it says here, when you add the UN plus the VN, this whole sum here, the limits are going to be heading towards L plus L prime. This is why it's for this reason why we have the L plus the L prime here. And despite that, this whole thing here, we're looking at the sum. We're looking at the sum of two suites. Yeah, of two limits of the suite. Yeah, and then they put the subtract. Then they say WN minus the L plus the L prime. The reason why there is the minus sign here is because that's how it's supposed to be solved. That's how it's supposed to be. Yes, just like it is the way we've been given that equation. when you're looking at polynomials where they give you negative b plus or minus the square root of square root of b squared minus 4ac over 2a. You see there they put there somewhere there it was plus or minus. The first b there is negative, the exact same way it is for here. This basically here is it's here to make things easier, so at least we can end up having this at the end here, this at the end here. That's the whole point. Yeah. So the reason why there's minus here is just to facilitate the equation. Yeah, the equation that actually find what it equals to at the end of the day. Yeah. Just like an equation has a particular sign, the exact same concept here. It's just to help us actually find find whatever it is going to give us at the end of the day. Is so this whole thing here is just an expansion of this in addition to the sum of Vn and Un, where we've been given the limits L and L prime, which are the limits of the suites which we're looking at, which is Un and Vn. Not forgetting that we're looking at the sum of two suites, so it's going to be Wn is equal to Un plus Un. Yeah. Sorry. Oh, it says where is the Wn coming from? The Wn it represents the addition of two suites. It's just like it's like someone coming to ask me where did the Vn come from. The Vn represents another suite. Let's say, for example, we say we say 2 plus 3 is equals to 5. Then someone says, where is that coming from? It's coming from the fact that we've added 2 plus 3. The exact same looking for Wn. It comes from the fact that we added Un plus Vn, which gives us Wn. That's where the Wn is coming from. It's the addition of two suites. Yeah. Yeah, so that's for that. That's for this part here. Yes, then we now have a remark here. So here, it says if the limit Un is approaching infinity, the suite then Un is equals to positive infinity, and then the limit n approaching infinity is going to be equals to L, which is the member of real numbers. Already we know that where this L is coming from. We know that when we were looking at UN, normally an L is going to appear. Yeah. And then it says the limit here, then it says the limit n approaching infinity, the addition of the suites Un plus Vn is now going to be equals to positive infinity. So we have got this first one here, we're looking at the limit, which is actually going to give us positive infinity. Now, we're looking at now something different. Now, in this case here, where we've got two limits, where one limit Un gives us positive infinity, was the limit Vn gives us negative infinity. In this case here, we cannot add the two because they don't give us the same thing. At the end of the day, when you add these two, you still get negative infinity, and then that now gives you so in this case you can't just add the way we had added here. So here, to actually solve this, now find another way of solving it, you can use the hospital rule, other rules, where you now calculate the limits. Yes. So this is why in this case, when it gives you a negative infinity, and once the other one here is that positive infinity here, and since here we're looking at the addition of two suites, that means here we cannot add these two suites here until we have to solve for this one here, and then I'll find a way to actually find an answer that can actually be accepted. Yes. So that's now where we now have different types of ways to actually find the answer. Yeah, which we're going to look at as we are going to be moving forward. Yes. Yeah. So the first thing we look at look at the sum of two suites. Now looking at the product of two suites. Yeah, the product of two suites. So in this case here, when you multiply Vn and Un, we're going to be given Wn, the same thing. And we all know the limits for we all know the limits for each of the suites, which is L and L prime, which is L and L prime, just like always. Then just like always, we have to find a way to now to define this whole thing here to facilitate. So at least because if they just end here, if they just end here and they move on, it would be hard for one that should say, okay, now what's happening here? Where did this come from? And everything else is here. So, so the first thing here says that we show that the suite L, the suite L Vn, this L here represents the limit for Un. So it's multiplied. It's like saying L times Vn is going to head towards L times L prime in this case here. This here is different. Why? Because here we're now looking at the product. So it's going to be different than when you're looking at the addition of two suites of a limit. In this case here, we're multiplying two suites of a limit. So this here is going to be a little bit different from the other ones we have looked at. Yeah. This is why for this case here, it's L here, it's L times the Vn. This is now going to, the limit is going to be heading towards, so it's going to be heading towards L times the L prime. Yes, the L times L prime. We've been told that the constant, we've been told that L is born. So we've been told, it's been said, it's here. We've been told already. That means here they made our way very, very easy by them telling us that okay, L here is born, and then you know what, the suite Vn minus L prime heading towards 0. Just like last time we were looking at the suite Vn, it was heading towards 0 last time. Yeah, I'm not mistaken. Yeah. So, yes, then we refer to go back to position 322. Okay, which is here. This one here, where this one here where we're looking, where it was heading towards 0. We did this on Monday. Here we go. Don't remember, just try to go through. Yeah. So we're looking at the product of two suites. It's still going to give you Wn, and the limits stay the same. L and L prime. L for Un, L prime for Vn. Then in this case, for us to define the Wn is equal to Un times the Vn. This is how it's been defined. The first thing they say is that L times the Vn is heading towards L times L prime. We know what L is, we know what L prime is, and we know what Vn is. Vn there is a suite. The L and the L prime, there are two different limits, representing two different suites. L prime for the Vn, then the L for the Un. And then we've been told that the L is 1. By definition, it's been given. Yeah. Then we've been told that what have been told, the suite Vn minus L prime is heading towards, in this case here, now things have changed. This time here, instead of the Vn heading towards L prime, this time Vn minus L prime is now heading towards 0. You see? So in this case here, they've now used this L prime, which at the beginning this L prime was the limit for this Vn. Now things have changed because now it's now been introduced in this very equation here. And when that happens there, the limit changes. It now starts heading towards 0, and not the L prime anymore. Yes. Yeah. And then now like just like we have, remember, it's this here we're looking at them. So we know that our Vn is equal to our Vn here is equals to the Vn minus the L prime. So to redefine this, actually going to be like that's actually going to become L, right? It's Vn minus L prime. This here is the same as this here. Where is this coming from? From here. This way it's coming from. This is where it's coming from. Yeah. And then now, because of that, the conversion is also going to now be heading towards zero. Going to be heading towards zero. Here it was heading towards zero. We had to write it in a different way to make things a little bit more easier. So we got this, replace the Vn with this, which is going to be here, and then now the conversion was now heading towards zero, which is now different, which is going to be here, which is here. Yeah. And from there, we've now been able to define the fact that the suite L times Vn indeed is heading towards L times L prime. Why? Because because when you try to present what does this Vn, what's the equivalence for this Vn? We found it here. We found that the limits changed. After finding that, we now replace this Vn, this Vn. Sorry, we now replace this Vn with this, which is here. The converging was heading towards zero, but everything else can remain the same because this here and this here, it's still the same. There's no difference. The only difference is that the Vn here has been defined in a different way. It's now being written as Vn minus L prime. This part here and this part here, it's the same thing. There's no difference. The same thing. There's no difference. Yeah. So this is for the Vn. Now the Un, as usual, the Un heading towards L prime. Sorry, the Un heading towards L. When you get that L, you put that L with the Un, becomes Un minus the L. Just like the Vn heading towards zero. The sweet Vn here is converging, meaning that it's one. Just like in this case here, the L was one. Now in this case here, when you're looking at the Un, the Vn here becomes one because it's converging. Yeah. Then in this case here, what do we do? Yeah, in this case here, what we do? We multiply Vn and Un, and then the Un, we wrote the Un as Un minus L, which is going to be here. And here we know that this here is going to be heading towards zero. That we already know. That has made this whole thing be converging towards zero. Yes, yeah. And then this is then it says so this whole so basically this whole thing here becomes different. How it becomes different? You have to go back and now you have to go back and fully understand what it was saying here. We're looking at the Vn times the Un last time, yeah. And then I think the limit there should have been zero. Yes, I'm looking at it on Monday. Yes, yeah. So in this case, we will now write the Un times the Vn. It's going to be equals to Un. It's going to be equals to Un times Vn minus L Vn. L Vn plus LVN equals to the UN UN minus L plus LVN. Yeah. So this here has been written as this here. We know where this LVN is coming from. This LVN is coming from here. We were given as we're trying to define as the Vn times the UN, which is equal to the Wn. Yeah, so this here were given in the question here, and this here were given is also here as well. It's also here as well. We were looking at the UN. So basically, UN times Vn can also be written like this. This is how it was written. Yeah, this is how it can also be written because everything here that we introduced here has already been given. It's like it's just appeared from nowhere. It's been given in the question. It's been here. So it's been given in the demonstration, the definition has been here. So how they wrote this was in this way. Yeah, was in this way. Yeah, was in that way. So it was this because of that. They maintained the Vn there, minus the LVn, then they added the LVn there. And then afterwards, they found that it's equals to un minus the vn. Maybe I think here, what can, let's see, what can we do? You multiply there, if, yeah, you can actually like, if you distribute, yeah, you can actually, multiply this there. Yeah, try to see what's going on. You move out the vn, when you remove the vn there, you get un minus l, which is going to be un minus l here. This vn here is still just going to remain there because we can't do anything with it. Yeah, so that's that there. When we simplify this, it's actually going to give us this. Therefore, un times vn is equals to vn open bracket un minus l plus l vn. Yes, yeah. And then for that, yeah, then being given this, actually finding this, which is equals to un times vn, and we know the limits in this case here is l times l prime. Why? Because our sweets, the limits are being multiplied, and therefore the limits themselves are going to be heading towards the product as well of the limits themselves, which is going to be l times l prime. Yeah. So this is for the product of two limits of the sweet. Yeah, so before I move to this, are there any questions of the sort? Are there any questions? Anyone with the question before I move on? I don't want it to be brought back. So ask the questions now before I proceed. Okay, perfect. So
I have a question. I don't know if I go to where you say the limit un is being represented by L, but I don't know why we are subtracting the same un minus the L.
where? Hello? Which point are you talking about? Yeah. Which point are you talking about?
I'm talking about where you say the un is representing is being represented by the L limit. Now where we have the un minus the same L, how is it that coming about?
Well, sorry, repeat your question. Wait, just show me what you're talking about.
Just where the même la soute un tombe vers L, donc la soute un minus L.
Here?
Yes.
Or you're wondering where this has come from?
Yeah, because the L is representing the un.
The L is representing the limits. This L here is the limit of un here. And just like the other things we looked at, what normally happens is that the very sweet is subtracted from the limits by definition. And then in this case here, when this happens, this whole sweet, because now the moment that you bring together the un and the l, meaning that this whole thing here becomes a different sweet of its own, meaning that it now needs a new limit. It needs to head towards something. And then in this case here, everything changed. And then now say heading towards the zero. So happened here. Just like here. Just like this point here. Vn alone is a sweet. And when this Vn alone is a sweet, the limit of this very Vn here becomes open. the moment that you incorporate the Vn and the L prime, you make them one equation, meaning that this whole thing becomes a different suite of its own, and therefore it needs to have its very own limit. This is why it's now heading towards the zero here. So basically, this L is the limit of this L prime is the limit of the Vn alone. This L here, so this L prime, this L here is the limit of the Un on its own. On its own. Let's say, for example, what you've been given is the limit of n approaching L of the Un. That's basically what I'm saying. Yeah. So the moment that now you are going to get that very limits that you've been given, and you make one equation, therefore making this whole thing become a whole different suite, meaning that you now need another zero. And it's just coming from the fact that they are trying to find a way or them to show you different, of them to try and redefine what they're talking about. So basically, this here, this here is just coming from, it's coming from the things you've already been given. We know the UN and we know the UN and we know the L. So here, the only thing we're trying to do here is just trying to bring them together and show you a different possibility that these two, when they come together, they're going to form one suite, and that suite will have its own limits. It will have its own limits. Yes, yeah. And if you look at the other things you've been given, the UN minus the, this principle has been applied so many times. When you go back, it's there so many times. So this is the very same thing. Yeah, but this is how they define whatever it is will be given. So here, this is the part of them trying to define the product of the UN and the Vn. Yeah. Again, I don't know how to answer the question.
Yeah, it is better.
Any other question before I move on? No more questions?
Mono, I've got a question. Okay, can you try, please repeat what you talked about when that suite, like when you bring together the verses, the UN and the L, making it one equation when it's heading towards zero, what happens to it? Can you just re-explain on that point?
Okay, all right, just give me a second. Sorry, repeat your question.
I'm talking about the thingy that you said that when we bring this UN together with the A, when we make it as an equation together. And then I was asking, what happens? What do you do when it's heading towards zero? This zero here.
Well, it now becomes the whole new suite. So in the case like where like at the beginning, the original suites, the limits of the suites was UN and Vn. So what happens is that, let's say for example, there is no suites there. Like from the very beginning is the UN. That's the original suite. So what happens is that that suite has a limit which is going to be L, okay? So it's going to be the limits n approaching L. Then the suite L will be given, whether suite equation, whatever it is UN there. So the UN has its own suite which is L. So you solve it just like that. Yeah, just like that. Now the moment you're now going to bring in that very L, and make it, and incorporate it with the UN, which is in this case here. You get this very limit, and you incorporate it here, meaning you've made a whole new suite. You made a whole new suite, which is now going to be UN minus the L. in this case here, the very limit of the UN has been used, and they've made a new equation. It's just like, for example, let's say we've been given the limit x is approaching 3, and then the equation we've been given, like on top there, what we'll be solving is 2x plus 4. It's 2x plus 4. Yeah, 2x plus 4. Yes. Now, the moment that we are now going to get that very 2, we say the limit x is approaching 2. We get that very 2, and then now we now, maybe let's say we add or subtract it from the original equation, meaning that we've now changed everything. That whole thing is now going to be a new equation. Meaning, if you may try and solve it, like how you solve how you solve limits, you're not going to need a new limit. So let's say it's 2x plus 3. Then the limit for that equation was the 2. Then we bring the 2 there. The whole thing will change to it now being 2x plus 5. And 2x plus 5 and 2x plus 3 are two different things. Yeah. So we have to now find a limit of its own for the 2x plus 5. In this case, we can say the x there can be approaching 5. So it said number 5 there is now going to be the new limit for the equation, because we incorporated the limit of the original equation. Just like here, our original suit of the limit was the UN, and the limit was L. So we brought that L and made it A, and then made a new suite, which was now UN minus L. Once we do that, what happens is that you now have a new limit, which is now going to be the 0. Is why we now have the 0, and then from there you now be able to solve, because because you now have a new limit, you have your UN and you have the L. Noting that the UN can be equal to whatever is being given, the L, the exact same thing. So that's why it's like that. Yeah, I don't know whether I'm answering the question or not. I hope I have.
All right.
Wait, like you've understood?
Yes. Thank you for the clarification.
Yes. So we've done with the product and product and the sum. I hope you guys have understood those two concepts, because they're very easy concepts. Yeah. They're very easy concepts. So I really hope you've understood. Just try and just not like the definitions, like how like it's been redefined. Just write WN plus WN is equals to UN plus BN. Then there it says we know that the N is greater than the small n greater or equal to the capital N. Then there exists what. Just write those definitions there, so this you'll be able to remember. And then you mention, say, okay, no, for that one there, it's equal to number 2. But then we say that they actually, and then they say that in the notes, the UN minus the L, when you find the modulus of that, whatever it is you find should be less than equal to number 2. Then from there we can note that whatever it is you find here should be very small, because equal to number 2 already give us a very, very small value. Yes, then we now know, okay, we have 2 suites because UN and BN. Meaning that here there should be 2 different limits. One here, the limit is L, the other one here, the limit is L prime. But the one thing you should note is that the reason why they're using letters here is just for them to just show you how to solve. Yeah, it's for them to just show you. Normally, like when you look back in Zambia, they normally give like numbers. Here they give letters. It's the same thing. So don't let these things here confuse you. The reason why they're here is just, this is why like here they'll tell you that no, the N is a member of natural numbers, meaning that it can be any number. So in this case here, why these things are here, just for them to at least give you a wide array, So that if you want, you can put your own numbers to just help you understand things on your own. There are others maybe who can say, no, I'll choose to where there's L, I'll choose to put 3. Because 3 is easier for me to actually work with. Others say, no, I'm going to use 20. Others, no, I'm going to use 70. This is why they use letters here, so that you are able to incorporate your own thing to help you understand the way, your own way. This is why it's here. But don't let these things confuse you. Quite right, yes, yeah. Quite right, yes, yeah. They can give you a limit which is going to be a letter. They can say, they can say AO, yeah, they can say AO. The exact same thing, don't let that AO there already defeated. No. Just get that AO and replace what you have to replace. That's how it's supposed to be. So these things should not sort of shake, that's here to just help you replace whatever it is you want so that you can solve them your own way and find a way to understand things your own way. This is why that is, yeah. Otherwise, guys, Analyse is very, very simple. Believe me, you guys are taking 18 out of 20. Yeah, it's not that. That's only because maybe your prof would just a little bit stingy, and all that. Even 20 is very, very possible to get to Analyse. As long as you just follow the concept, you remember what is supposed to be done, you read your notes, you get your points, you apply your notes in the questions. Analyse is very, very simple. It's just math. But it's very simple. Nothing was made about it. Yes. Yeah. So, yeah.
I just want to find out something.
Yeah.
Yesterday, NS sent a message to the group saying that we'll be doing a TD based on suit geometric and arithmetic, and said that we should make sure we pay attention because that's what to focus more during the TD. So I was just wondering if you're going to teach on arithmetic and geometric suits.
Oh yes, yeah, I'll teach that once I'm done with this. It should be, as we haven't yet reached that point there, but I talked about it at the very beginning about geometry. I just said it just appeared there when we were looking at different types of suites. Yes, yeah. It should be like at the bottom somewhere here. Yeah.
All right, thank you.
Yeah. I'll look at it eventually. Yeah. Yes, but anyway, so that's that. That's some products and products in the and the sum of the suites. Yes. So before I break, he said you look at those things today or something like that.
Yes, he said that's what to do be based on.
Okay. Since we're looking at those things today. Okay. So I'll roughly explain on that. Yeah, on suite arithmetic and geometric. Yeah, so basically just like last time, at the very beginning, I told you how we've got different types of suites. So just like there we got suites arithmetic and suites geometric. So what normally happens is that for a suite arithmetic, that's where you're not going to introduce the M. And that M is a number of real numbers. Remember that M was introduced when we're looking at the big M, right? Yeah. So in that case there, for a suite arithmetic, there's going to be an M. Yeah, there's going to be an M. And that M will be a number of real numbers. So that M can be any number. So basically, let's say analyze arithmetic, there's going to be numbers, real numbers. Yeah, real numbers. Yeah. So normally what happens on analytic arithmetic is that basically one of the major like forms of writing it is that you get the normal way of how you write it is a UN, right? Yeah, is a UN, right? Yeah. So what you do is it becomes that UN, that N at the bottom there, you're going to say +1. And the reason why that is +1 is because, like, let's say you're trying to like find different suites. Maybe you find the first suite, the second suite, the third suite, noting that N at the bottom for the suite UN is actually equals to any number. I don't know if that number is a real number. Yes. So normally what happens is that it becomes UN +1 is equals to UN plus R. And that UN there represents a suite. That R, that R there represents it represents basically the suite arithmetic. So analytic arithmetic, what happens is that we've got different properties. So let's say we've been given switch 1, 2, 3, 4, 5. Note that that arrow there, that's there, represents the switch arithmetic itself. So the main equation there is UN, there is a UN, that N there is +1. Yeah, that N there is +1. Let me do this. That is very good what I'm talking about. I'm just drawing this group second page and you need to show just hold on. How do I be able to get my hand out in that? Oh yes, that is the with so the person with the 100 there. Yeah, sure, go ahead, talk. Was the hand up by mistake or something like that?
Oh, you are saying there's somehow right n+1. Could you use a point that will like specify exactly what it is? Because you're saying +1 and we're not really seeing it.
Yeah, that's what. Sure.
Can you guys get me?
Yeah.
Perfect. Just hold on a second. So I don't know whether you guys are able to see my handwriting, but just to help you guys so I don't get confused. Let me just stop this sharing. Okay. Okay, so okay. So what I was saying, I don't know whether you guys can see. Chill. Let me see. I can't even see. Okay, let me just leave my camera. Give me a second. Okay, so I can see myself. Let me increase. Oh, sorry. You guys can see the paper, right? The plain paper.
Yes.
Wait.
Okay, perfect. sure. Let me do this. What's this? Okay, so what happens is that under a sweet, you've got two types of sweets. There are two types of sweets. You've got sweets, you've got a sweet. Can you guys even see what I'm writing?
No.
Use a
How about trying to use a pen?
Okay, let me use a pen. Okay, so under a sweet, you've got two types of sweets. You have one. Let me do this. Yeah, you have one, a sweet arithmetic. Yeah, is the first sweet you have. The second sweet you have is a sweet geometric. These two are the ones you have. These two are the ones you have. So now for this type of sweet, for the first type of sweet, what happens is that normally, at a sweet, a sweet is written as UN, right? So this here is U. Written as UN. Now under a sweet arithmetic, what happens is that in this case here, you're looking at different types of sweets. Yeah. So in this case here, the way normally it is that for a sweet arithmetic, so we'll say an example one. So we'll say sweet A, which means arithmetic. I'm just writing it like that. So by formula, like how you actually get to having different types, different groups of sweets. So the first thing is you have your sweet UN, right? Now this UN here represents a normal sweet. Now for you to find different types of sweets, for you to find sweet 1, 2, 3, 4, 5, 6, 7, what happens is that you're going to say this N there plus 1 like that there, which is going to be equals to a sweet, a normal sweet. The reason why here is plus 1 is because you're trying to find a sequence of different sweets. This is why it's called, this is why it's called sweet arithmetic, because it's a sequence of different types of sweets. Yeah. Then this UN there, you say plus R. This R here represents your sweet arithmetic. Yeah. It's basically we'll just say it represents your sweet arithmetic here, like a part of the sweet arithmetic. So let's say, for example, we know that this N, we know that this N here is always a member of real numbers. This here we know. Yeah, this here we know ourselves. Yeah, by definition. So if this N here is a member of real numbers, these real numbers, they can be equals to anything, -1, 0, 2, whatever, up to N, whatever it is. This N here means it goes on. That we already know. I just said from him, but then we all know where real numbers start from. I mean, just a simple example. So yeah, so now let's say for example, that this N here is going to be 0. Let's say this N here is going to be 0. Here. So here we'll say, the first thing we'll say that where N is equals to 0, right? So what happens here is we're going to get this. So here it's going to become U. This N here is 0. 0 plus 1 is going to give us 1, right? Going to give us, it will be equals to your sweet. This N here is going to be 0 plus your R, where N is equals to 0. Then now, the second one now is going to be where your N is equals to 1. Where there's your N here, you put 1. There's going to be U2 is equals to U1 plus R. Yes, yeah. Just like that. And then now, what happens is now, let's say for example, okay, then I'm sure you've seen now how you write it like in sequences, right? It's your n here that should be equivalent to something, because it's your n here you're trying to change. Yeah, it's your n here you're trying to change. Yeah. So what happens is that now this here, this is property 1, property 2. Now there's another property whereby it's going to be your un, your sweet un there is going to be equals to u0 there plus nr. Yeah, nr. There's this here. Now this here is actually now what helps you. This here is now what actually helps you whenever you're looking at trying to find different sweets and a sweet arithmetic, because this n here represents something and the n here something, the r something. This sweet u0 is going to represent something as well. So you keep this. This you keep. So we'll name this as 1. Yeah, we'll name this as 1. And then here, we also note that by definition we have to note that for all members of n, this n here is this n here, this very n here. Yeah, for all members of n, sorry, for all n is a member, or except for all n is a member of real numbers that we know, right? Yes, yeah. And then we know that this very n should be greater or equals to 0. We got these points here. This we always have to know. The reason why we write this normally like at the end is because you have to like define like why the reason why there is n, because someone cannot know what the n here is without you writing this. How would we all have known like what our capital N is if they didn't say n is a member of natural numbers? This is how we knew, because if you just write your n then don't say anything, we won't know what it means, and it means your work is going to be incomplete. Yes, yeah. So now what happens is that now let's say so basically this analytic arithmetic, what happens, you have your suites, you have your arithmetic representative, you've got the other suite here, then here becomes n plus 1. So what happens is that in this case here it becomes n plus 1, then now this n here is going to be equals to something. The way here n was equals to 0, n was equals to 1, and goes on and on. But then what you normally keep is this one here, because this here is actually what you're going to use. Yeah. So this is for that. Yeah, this is for you keep this. Yeah, you keep this. Even this, you keep this, and you also keep this. Un plus what? Sorry, shoot. Okay, all right, it is right. You also keep your un plus 1 is equals to your un. Is equals to your un plus your r. You keep this. Yeah, you keep this, and you keep this. You're going to keep this too. Very important. You keep them and you keep them, because this here is going to help you like write this here will help you write a sequence. Here will help you write a sequence of different we'll help you write a sequence of different suites. Yes. So this here is a suite arithmetic. Now for suite geometric. So this here, that was I. So this is now 2. Yeah, I will now say for a suite geometric. Yeah, for a suite geometric. Just as always, we all know that a suite is represented as UN like that, right? We'll do this just to show a difference. But honestly, suite is written like this. Now for a suite geometric, what happens is that in this case, remember that for a suite arithmetic, for a suite arithmetic, this one here, for a suite arithmetic here, there exists here what we had a capital M, right? And a capital M, and we say this M is a member of real numbers. This here is for a sweet arithmetic, and M is introduced. For a sweet geometric, what happens is that for a sweet geometric is that, in this case here, what we use here is an M. So is an A, and then is an A. Yeah, is an A. Then this A, just like the M, is also going to be a member of real numbers. So geometric, an A is introduced, arithmetic, and M is introduced. Remember, this A and this M, guys, they represent something. Why is A here is just for them to just show a difference, because here they can't put M, here they put P, D, I don't know, even here X, Z, name it. But then they just chose that no, we just say M, and no, we just say A. As long as they show a difference, and at the end of the day, we know that they're all members of real numbers. This is why it's just to help us know whatever it is that has been given. So for a sweet geometric, it's almost the same as a sweet arithmetic. The only difference is that for it, somewhere you're going to multiply, somewhere you're going to multiply. So what happens is that what is that? Okay, yeah. What happens is that the same thing. You're going to keep the UN plus 1 going to be equals to, remember in this case here, since it's a geometric, we have A. So in this case it's going to be A there times our UN. Remember for geometric, sorry, arithmetic, there was an R, and here it was addition. Geometric, here it's multiplication. Yes, yeah, it's multiplication. Yeah. So that's that. So maybe let's say, yes, maybe let's say, for example, you've already been given what your N is. As usual, you replace where the N is and everything else, and yeah. Normally, what actually happens is that let's say,
There's
okay,
a part we can't see.
Mono,
oh,
There's a
can't
part
see?
we
we
can't
really
see.
can't see what you are saying.
Oh, okay. Can you see that? Can you see now?
Yes.
Okay, yeah. I was saying for a sweet geometric, it's like this. It's UN plus N is equals to A times your UN. And I say geometric, you multiply. For arithmetic, you're going to be adding. That's the difference between the two. Then when you say that for sweet arithmetic, they introduced an M, and then for a sweet arithmetic, they introduced an A. Yeah, they introduced an A. Yes. And then in this case here, what happens is that the A and the M is basically, the A and the M is basically equals to any number as long as they're real numbers. That's the whole point, as long as they're real numbers. So now let's say for example, we've been told that N, where is that thing? Okay, we know that N is equals to, oh my goodness, is equals to 0, right? Yeah, N is going to be equals to 0. Yeah, N is equals to 0. Yes. So one of the properties you also need to know, yeah, under sweet geometric, is that this is actually very important. And sweet geometric is that for all members of N, for all N is a member of natural numbers. Yes, that we know. Then we know that our sweet UN, our sweet UN there is actually going to be equals to U0, where times A to the power N. This here we need to keep, yeah. This here is a 0. So this here is a 0. This dot here, in Analyse, you don't say times. Actually, just in Morocco, you don't say times, you put a dot. You only say times, maybe like if you're trying to say like 10, let's say, if you're maybe trying to say 3 times 10 to the power negative 18, that's when you use times. But for you to say multiplication, all you put is a dot. Once you put times, it becomes something different, and your whole thing can be wrong. Unless your professor is going to feel, a little bit sorry for you. But normally, guys, make sure you get used to using a dot to represent multiplication and not using the actual sign times. No, don't do that. Yeah. So we keep, so we're going to keep this. This here is a property. property 1. It's a property. It's a property under sweet geometric. It's this one here. So let's say, for example, our n is equals to 0. What's going to happen here is that it's actually going to be equals to, so let me write it down and I'll show you. Bu0 is equals to u0 times a over 0. Yeah, so let's say, for example, that our n is equals to 0. We're going to be given, what we'll find actually is going to be un minus, so un is equals to u0 is equals to u0 times our a to the power 0. Yes, and we all know what anything with the power 0 is equals to. We all know what that is equals to. So that's that there. So basically, when I switch geometric, you multiply. Arithmetic, you're going to add. Yes, the same thing, the same sequence, the same thing. It still stays the same old thing. There's not much of a difference that's there. Yeah. So, and then make sure you keep the un is equals to u0 times a to the power n. That's a property. You give that property. The same thing with the other thing we looked at under switch arithmetic. This one here, where it was the un is equals to u0 plus n r. You need to keep that too. Yes, yeah. Let's see what else under switch arithmetic. Let me try to remember. Sure, let me just try and look for a question. Sure. Okay. Just give me a second. Let me just try to look for a question. It's up to this guy. Just wait. Okay. Anyway, so basically that's just that. And switch arithmetic and switch geometry. I don't have examples of switch arithmetic or geometry because they didn't really focus on that. They focused on something else. But otherwise, that we were taught, and we know that arithmetic you're gonna add, geometry you multiply, and the same thing. Just keep the same sequences, show the same ways of writing them, the same sequence. Just keep it and the same thing. I'm sure he will give you guys examples, but at least you have a background like of what is actually supposed to be happening. You know. Yes. So geometry, guys, you have to multiply. Arithmetic, you add. Yes, just like just like sequences. Yeah, in math. Yes, yeah, just like sequences. The exact same thing. Although I can't remember that formula. I can't remember how we used to do that, but I just know that it's similar to the sequences we did back in time. Very, very similar. And even then, we also had arithmetic and geometric. Yes, yeah, I remember symmetries. Sorry, sequences. Yes, yeah. Okay. Yeah. Someone said what's M? M represents any real number. The reason why they chose M, I guess they said no, let's just choose M. So they just chose M. Otherwise, M represents any real number. Yes, it's a sign that they use in under switch arithmetic. They can use A, maybe others can use B, maybe others can use D. Well, my professor chose to use M. The exact same way under geometry, he chose to use A. So I guess as long as you can at least differentiate between the two, yeah, that's the whole point. Otherwise, they all represent numbers at the end of the day. As long as those numbers are real numbers, that's what it's supposed to be about. Yes. Yeah, so that's that under that. Yes, yeah, I didn't know that you guys were going to look at switch arithmetic and geometry today, and that I was supposed to actually teach you guys. I didn't read those messages. Yes. Yeah, if I did, I would have actually gotten some questions. Yes. Yeah. But yeah, at least you guys know a little some. Yeah, I'll tell Enes that you guys didn't do it like so deep. And since he already has questions, I'll text him and tell him that he should like give you guys more information on it, and just not the base of giving you, so that you can understand more of it before you actually start solving the questions and everything else. So I'll do him. I think let me even just do him right about now. Yes, yeah. Okay.
Mono,
Yeah.
can you also do as a favor by sending a picture of what you are doing on that day?
Okay, sure. That's true. Let me just text Ines because I know once this class is done, I'm going to forget. Where is he? Okay. But if you guys have questions, please, you can ask. Go ahead and ask. Okay. Okay. So let me see. Yeah. So that's on the arithmetic and the geometric part. Yeah. And well, okay. So like Daliso yesterday had asked me. He said that wait. Can you guys hear me?
Oui.
Okay, yeah. So yesterday, was it yesterday or the other day? I don't know between the two. But then he had said that you guys had a little complaint on the fact that you guys at times like have Analyse twice a day. Like normally on Fridays, it's a must to have it on twice a day because on the calendar it says in the morning and also in the afternoon. So yeah. So he said you guys had a little query on the fact that you guys at times like have it twice a day, and then it's like you guys are putting more attention to the Analyse and like having a balance with the other things they're doing as well and all that. Yeah. So yeah, so I had spoken to Ernest about it. I told him that no, this is what they said, and yeah, I don't know whether he already, I don't know, talked to you. I don't know. Yes, yeah. So I think what can be done is, since you guys like meet in his like times that maybe he says, I don't know, in the evenings, I guess, and all that. Yeah. So maybe you guys should like try and tell him that no, I feel like it's a little bit, I don't know, it's a little bit too much or whatever it is, yes, and all that. But then also, I know it's not everybody who has a complaint that you feel you're learning Analyse more and just taking up like more attention. So I guess you guys as a group, you guys should like talk about it and then you figure out what works for all of you guys, as long as it's convenient for at least everybody, or at least majority. I know it can't be convenient to everybody, but it's most people, and then others can just adjust, because that's just how life is, I guess, sometimes. Yes, yeah. So you guys should sit down and then talk about it and then find what works for you guys, what times are best for you guys and all that, so that you are giving attention to like every module as everything you're doing, so that you aren't just looking at one thing, because at the end of the day, as much as Analyse is important, same with algebra, even the other modules too are also as important as well. So you really have to make sure that you have a balance with everything, because it's just like because it's just like when you go to school. I'm going to give an example of like those who are going to do BCG. Yeah, those who do BCG. Normally, you only have like Analyse like once in a week. Yeah, once in a week. Yeah, no, sorry, twice in a week. That's the core and the TD. Yes, yeah, twice in a week. Yeah, and then what you normally have like majority because of so many notes. Because I'm sure you guys know that when it comes to subjects where there are notes, and in BCG, you're looking at where you've got biology, you've got things like geological subjects too. So those normally have got more classes. Normally you find that like bio, you can have bio like 3 times in a week. So will you come and tell me that no, because you've got bio 3 times in a week, you are going to put more attention to it? No, that's just how it is. At the end of the day, you have to now find what works for you and then find the way at least to reach each module equivalently, because what is it going to help you for it only validate biology, whilst the others you won't validate them? At the end of the day, you're going to have like 5 subjects you're going to end up carrying. Whenever it's carrying, or what do you call that? End up repeating the whole year. No, actually, no. You carry the 5 subjects. Yes, yeah. No, 5 is too much. You can't carry 5 subjects. You're guys going to repeat the year. That's the thing. Yes, yeah. So you really have to at least find a balance, find a way at least to meet every module halfway through. Because even just like those who are going to go do ENC, like, yeah, those who do ENCG, economics, what else is there? ENSA, SVT, I don't know, anesthesia. What else is there? Yeah, yes, yeah. Even just like those who are going to, maybe I don't know whether the people or the person, I don't know whether the person is here, the person who go and do pharmacy, because you go do pharmacy, maybe let's say you are mainly like doing a lot of maybe chemistry, so you can't just say no, I'll focus on this part of chemistry because I have it like all the time. No, you have to find the balance, like in each and every single what's it called, every single, what's the name, whatever. But whatever course you go do, there are going to be some things they're going to learn like more than the other things, because they require more time and more things, because you can't compare the time that's required for you to do mechanic du poids or the fluid. Yes, yeah, compared to what has to be done in Analyse and in algebra, because Analyse is a lot. You're looking at how to look at, because we're still looking at suites. We still have to look at we still have to look at the, what's that? How to solve the limits. Yeah, how to solve the limits. Yeah, there's still that. We still have to look at development limit. What else is there? Yeah, yes, yeah, and all that, yeah. And then then normally like under the limits part, how to solve limits, because now we're doing suites of the limits. Let's say the part of actually now solving the limits themselves and all that. Then there's now, it becomes a little bit here, because they're, looking at different they're thinking about like 4 or 5 principles that you have to use there and everything else. So that gets a little bit long. And that's why you find that Analyse has got more, like it appears more, and this is why Ernst as well tries like to maybe have like extra classes with you guys, so at least you can just try and explain and make things easy, because it's so evolving. It's very, very evolving. And what you do in Analyse, you're going to apply it even in physics. There's some things you're going to apply in physics, and you just have to like, yes, yeah. Otherwise, these things apply. This is why it's a lot. Yeah, like it's a lot. Just like math. They're just like math. I'm sure even you guys back in your schools. Well, I can't speak for everyone. I can only speak for myself. Me at the school that I was at, we used to have math a lot. Yeah, because math is very, very involving compared to other things, because you can't compare math to English. I can't compare math to English, because English don't have as much things as math has. Yes, yeah. So that's why it appears more like on the calendar and everything else. But then at the end of the day, just try by all means to just find a way at least to understand the things, at least just try and just find a way for you to actually be able to be at the same pace with everything else as well, because the other modules that don't need as much time as this subject needs as much time, because there's so much going on. As you guys can see, you're learning so many principles, what there's so many things that have to be learned. This is why it carries more time and everything else. It's not that no we are trying to make Analyse like very special and everything else. No, it's only because there's a lot of work that is under this. There's so much going on. Yes, yeah, that's why it appears more and all that. Yes, yeah. And then I'm reading your comment. Someone said you should be writing more often. I feel writing is more effective than scrolling that PDF. Well, yeah, writing actually is more effective than actually like using scrolling down the PDF and everything else. Yeah, so I'll consider writing more often. Yes, yeah, I think it'll actually be faster than me actually using the PDF. Yeah, yes, yeah, but I'll still have to refer to the PDF too, because there are like some things which I may not write, which are in the PDF, but yet they're still very important. But I'll still very much consider what you said, and the next time I will write, so at least you guys can understand better, because math is actually understood better like when you actually see someone writing and like looking at the PDF. Looking at the PDF is for other subjects. Math, you need to actually write things down. That's how things should end up, because now you see like how they moved from this point to this point to this point to this point to this point. Yes, yeah. So that's that. Otherwise, you guys just sit down and then like try and find like what works for everyone. We try and find like what timing works for everyone. Yeah, I'm sure that others who are okay with the timing, once others are not okay. Please, if you aren't okay with the timing, don't be scared to tell your friends that no, you guys, me, I feel like Analyse, we're learning too much. Let us try and find maybe a time when you can do like one extra class or whatever it is. Not all the time. Yes, you have to, at the end of the day, you have to speak for yourself, because if you want to speak for yourself, believe you me, someone one can speak for you. You have to go there and represent yourself, because this is about you and not about somebody else. At the end of the day, it's going to be you alone in that paper in the exam room. So make sure that you tell your friends that no, me, I feel here is a little bit too much, or me, I feel no, here we need to have more of this and this and this. No, I feel here, whatever it is, yeah. Despite others may like, we all know how people can be. They can they can tell you, they can be like, nah, maybe you're just lazy, yes, not serious, or whatever it is. No, you just tell them that no, me and few here is like this, or I said no, me and few we need to learn more of this, because guys, this here, this at the end of the day, as long as you explain to your friends and you tell them where you're coming from and you make them understand, I'm sure we're all human beings, even though others may be a little bit somehow. As long as you've spoken and you present yourself, if no one is listening to what you're saying, and they're all against your suggestion, what do you do? Yeah, what do you do? You can text either Ains or I. You say, no, Mona, personally, I thought the guys this, and this. They are not for the idea, but for me, I feel this will really, really help me. And you bring it out, you bring out your points, you make either of us understand. So at least everyone is being helped at the end of the day. Yes, yeah. And then there are times when people text me and I take long to reply, or maybe I forget. The thing is, guys, I forget. So what you guys can do is, if you really have a question, just call me. Yes, you just call me. And this, if you call me, it'll be more serious than like a text, because a text, I'm going to like, I'll look at it, I'm like, oh, okay, no, that guy, or maybe that person has a question, so I'll get back to that person. Then now the day is going to come, I don't know what I'm going to be doing, maybe I'll be studying, I'll get carried away, and that's how I'm going to forget. So if you guys really have questions, like if you have questions, make sure just call me. Yeah, just call me. And you call me, tell me who you are and everything, so at least I know what's up, and at least that way I'll actually like be, because texts I forget. I know that there's someone who sent me something yesterday, and I've literally just remembered just now as I'm talking. Even some other person at that time asked me a question too. I think the only person who I answered was Kasonde, because then I was actually on my phone. Yes, yeah. So make sure if you have a question, just call me. So at least I won't forget, because text I forget. Text I forget. So just call me and everything else. Yes, yeah. Otherwise, that's that. And what else? I don't know. Does anyone have a question? No questions? Okay. So anyway, we're going to end here for today. Yes, yeah. Make sure you guys should still honest. You should you should discuss as a whole, and then you come up with something. Then you tell Ernest about it, because he's the one who takes you guys in the extra classes that you guys have. Yeah, because I know there are others who feel it's too much. So those who feel it's too much, make sure you tell your friends. You present yourself. Don't feel shy. Please tell them, so that you can actually reach halfway through and you understand each other, and you actually can do something that will help everybody and not just a small group of people. Because we want, okay, I don't know about others, but then for me, I want all of you guys to go to your schools to do very well. All of you guys should move. No one should end up having to repeat a year. No, all of you guys should move. You guys should move. Your stories should be different. Make sure your story should be different. You guys should move. You move from 1 year to the next year, just like that. You progress. So make sure you guys will talk. You tell people if things are not okay for you. You say no, me here, guys. Here, this isn't okay. Because if you want to say, we're going to assume that you understand. The same thing with at times you guys say you guys say when I ask you guys have questions. You say, you be quiet. So I assume you understand. If you don't understand, you say, Mono, please, I don't understand. Everything is said, nothing, zero. I don't get anything. I'm just lost. You need to say, even though it doesn't matter how others will look at you, others will think that, no, you're just not learning. No, it doesn't matter. You're not coming here to learn for them. No, it's for you. Because if you don't understand and you just give up and say that, no, it's just like this, whatever, it'll be you who's going to go suffer. The concept here is just for you, at least you just know the small, at least you just know the background of what you're going to learn. Because believe you me, I'm really glad that I actually learned Analyse before going to my school in the first place here. It actually made things be easier. At least I was able to say, okay, no, that thing. Because trust me, the way Analyse is taught when you go to the faculty, one thing is the Moroccans, they've already done the such math, like a part of the math in their back, so they know. So even the professor will assume that, just like any other module, they assume because you've done it in your back that you're going to remember it. So they'll take it, they'll be like, no, you already did this and just applying this. So instead of you guys going to your schools and then being lost in what's being taught, this is why these summer classes are actually here. So it helps you guys, at least when you go to your schools, you're able to grasp things very, very fast. Because believe you me, it's very, very hard to go to school learning things in French to start with, and learning things in French. There are some professors who speak very, very fast. You won't get anything at all and everything else. But at least if you have a background of what's being taught, it'll be easy for you to actually say, okay, no, here it's this, no, here it's this, no, here it's this, and everything else. Yeah. So make sure you guys take these lessons very seriously. You go through and everything else. So when you go to your schools, life is made very, very easy for you guys. So you guys don't suffer, and you actually do very, very well, and you make your family proud. At the end of the day, make sure you make yourself proud. Yes, yeah. So that's that. Otherwise, I'm done talking, guys. I've talked so goddamn much, and I'll send that photo. Those things I was right now, send the photo right about now. Is otherwise, as I said, questions, just call me, please. If you text me, guys, I don't know. Guys, I don't know. I just don't. I get so lazy. Yes, so that's that. Otherwise, guys, have a great Friday. Have a great weekend, and take care of yourselves. Yeah, and make sure you guys talk about what I've said. You guys should talk about. Please do that so at least we can move fast and help each other too. Yes, so bye, have a great day and take care of yourselves, and God bless you all. Yeah.